Not quite good enough. X cubed over 3. Bless you. Minus negative. That's plus, isn't it? Which makes that just X squared. Negative 1/5 plus 1/3 plus 1.
Yeah, negative 1/5 minus, I said I had minus 1/5. Plus 1.
It's so frustrating. Just cracked my back. So Michael, your integral negative 4 plus x squared plus 2x. Oh,
Yes.
it's minus the 1 x squared.
Yeah.
Dang it, I screwed up the sign right there. I almost had it. What, 13, 15? So close.
Wait. I said 7 pi over 15. That's 7 pi.
Did it say calculator or anything?
Whatever. Tell me what. Negative 1/5. Two three questions on that.
Did you get 7 pi over 15? Okay. Oh, sorry, that was hidden. Is that also no calculator? 13?
13 calculator.
That's the easier one.
It is the easier one.
Uh-huh. Here we are.
Unfortunately, I will be using a calculator.
I didn't read calculator.
That's the spirit. That's the way to not see that. Are you getting something like pi over 6? Okay.
It always happens.
How's that going? Okay, cool. That has a couple wrinkles that you will eventually add in. Like it doesn't always go around the axis, for example. It can go around a different horizontal or vertical line. And things change a little bit. But if you are doing well now, you're fine. Okay, let's go. First of all, look at that test thing. Just going over a couple of notes. That test review, again, I think I told you this, but I'll say it again. I don't require that you do that test review. If you want to do all of it, great. If you only want to do the ones that you feel you need to practice on, great. If you want to do none of it, that's fine too, I suppose. And I will post a key online today, and I will be here before school tomorrow if you want to go over any last minute things. A couple quick notes just to review, and this is in your notes already, which wouldn't be a bad way to study if you looked over your notes. For position, velocity, acceleration, and speed, I think you know the big idea is that acceleration is the derivative of velocity and such. How do you prove speed is increasing? Speed is increasing if velocity and acceleration have the same sign. And if they're working together, then it will speed up, and that's in either direction. What about this? Interpreting this. What is it? That is displacement or distance? That's displacement. Oh, sorry, from limits. Displacement, yeah? Change in position. You're allowing for negatives, so you're allowing for positives and forward, backward movements, so you're going to get change in position. If you eliminate the negatives, in other words, integrating, what is the absolute value of velocity? That's speed. Okay, if you integrate speed, you're talking about, I don't care if it's left, right, I just want to total up how far you moved in any direction, and that gives you the distance. That's the distance. Okay. But if you did something like this, that is position. Actually, let's call it t to 0 to u. That's bad. Sorry, that's position at time t. Okay. Work. Set 77. 77. I think you know the big idea on work, but the work is the integral of rho, d standing for depth. No, try again. Distance. Rho, distance, volume. Okay, the distance you are moving the fluid slices. Okay, after that, kind of depends on what kind of case you're looking at. Constant x, varying x, symmetric x. There's one for practice on the homework. That's good. Set 76. Odd powers of trig. That seems like it's going okay with that, Joel. Okay, good there? Okay, you're stripping off, looking at the odd powers one and stripping off the single and then use them, right? Yes. Okay, 75 continuity. That seems like you're good. If it's in terms of what I expect, if I gave you, hey, here's a function, ax from x less than 2, and whatever x for x greater than 2, whatever it might be. And I said, hey, what does k have to be for this to be continuous? And I gave you multiple choices. Well, then I don't really look at your work. However you want to do about it. If you want to do sloppy continuity work, I won't know. Actually, I'll know and I'll be ashamed, but it's okay. If it says show this is continuous, or prove this is continuous, then you should be working from the definition of continuity, good limit work shown and all that good stuff, right? Right? Right, okay. Force, 74, force. How do you find force on a vertical face? Rho, D standing for? Depth. And depth is relative to the top of the container or the top of the fluid? Top of the fluid and area, whereas distance is relative to the top of the container. Let's go on to set 73, I think it was. 73. What's the antiderivative of a to the x? A to the x over natural log of a plus c. What's the antiderivative of log base a of x? Okay, this is something you want to study. Remember, it's the idea that we change the base like that. We pull out the 1 over natural log of a because it's a constant. And what is the antiderivative of natural log? Which you, in the interest of time, you should probably memorize. X natural log of x minus x. Where does that come from? It's from, yes, ultraviolet voodoo integration by parts, okay? It would be better if you had that memorized, you wouldn't have to lose time on the test to develop that. That's it. Set 72, what about the derivative? Why I'm running so low, let me go over here. What about the derivative of a to the x? A to the x times natural log of a. What's the derivative of log base a of x? 1 over x natural log of a. How do you take the derivative of absolute value functions? Piecewise. You write the function is piecewise. You do the derivative in a piecewise fashion. The gotcha is that, remember, to be careful about the differentiability at the endpoint. Sometimes you have a sharp turn there and you won't. The continuity part of it, the function will be defined there, but the derivative isn't, right? Okay. Step 71 is volumes of revolution by disk. That seems to be going well, volume by disk. And like all calc tests, I'm likely to combine ideas like volumes with integrating exponentials, putting together two ideas. That's pretty common, and you guys are good at that. What about the antiderivative of something funky like 4x over 8 plus 9x to the 4th? We've been doing that a little. You can expect that. How is that done? Was it? Pull out of 1/8, yes, exactly. So your goal is to get to one of the basic inverse trig, that one being our tangent, or that one, which is arc sine, and then the method is to get to that one and use of it, right? It'll go fine. Just do what you do. It's brilliant. Keep being brilliant. Like, get a concussion between now and tomorrow. You'll all be good. Okay? Sorry, today's lesson. This homework is due Monday, by the way. Woo-hoo, lazy weasels rejoice. This homework should be reviewed, I hope. And I'm missing a piece of my lesson. There it is. Spelling me. Okay. You did differentiability already. Yeah. So this is review. A function is not differentiable at any place the function is not continuous. So, talk to me some logic. True or false? If a function's not continuous, then it's not differentiable. True. If a function's differentiable, then it must be continuous. True. If a function's continuous, then it must be differentiable. If a function is not continuous, all right. So continuity implies differentiability, but not the other way around, right? In other words, subset. Differentiability is a subset of continuity. A function is not differentiable if there's a sharp turn. That you'll often have to prove. That's the hardest point on tonight's homework, is proving is difficult. You have to use the definition of the derivative, preferably the alternate definition. You had that on a test, but we need to practice it more, so I did include it in the notes. And then a function is not differentiable to vertical tangent. The reason being, if you have a derivative, which is the tangent slope, and that's rise over run, and it's going straight up, then the run is 0, and therefore undefined. The derivative is undefined, and so it's good. You with me? Okay. Analyzing differentiability from a graph then. At what point or points is the function continuous but not differentiable? Please give me one. X is -1. What else? 0. Why 0? Vertical tangent. Notice I'm saying vertical tangent, not vertical asymptote. Vertical asymptote would fall under discontinuity, right? Vertical tangent means the tangent line goes vertical. All right. Any others? 2, yeah.
But not continuous.
Yeah, 2 feels like it's not continuous, so I'm gonna go. I thought maybe it was vertical. At what x value is the function not? What does that mean?
When is it not continuous?
Oh, okay. At what? So I guess there is a difference, right? I thought this was redundant, but it's not. At what points at all x values that it's not differentiable? Give me them.
Negative 1.
-2, -1, 0, 2. Okay? At what points is the function continuous but not differentiable? Or sorry, differentiable but not continuous?
None of them.
No, that's not possible. Okay? No. Okay, cool. Let's go on to, try 11, please. This is a super duper gotcha at multiple choice tends to go badly. There are some multiple choices on the AP test. The averages are actually so low that you'd be better at just guessing, right? Their distractors are that good. Oh, I guess this is as good as the other one. I'm supposed to use it. All right, ready? What do you say? C. You all agree with C? Okay?
Wait, no.
No, we don't agree with C?
No. Because the derivative at 4 is D on top.
What else?
A.
A. A, C, D. We almost have, anybody want to go with B?
We don't like it.
No, B's not even, okay. So, A and C, if you're on A and C, then you have the right idea. If you're thinking D, then I think you're thinking F double. F double, this would be F double's graph, right? Okay, now, undoing, what's the antiderivative of x to the first, or linear? Parabola, right? Are you with me?
Yeah.
Okay, parabola, cube, parabola. Do you agree?
Yeah.
Okay, unfortunately I have parabola, cube, parabola, and parabola, cube, parabola. So, which one?
A.
Why must it be x?
Slope 4 to 5.
Okay. What if the problem had this? Then it could be either A or C. But because this point is defined, f prime at 2 exists. And if f prime at 2 exists, then f at 2 must be continuous. And the only way that that's looking at is that way. This has the right shapes, but there's no way you can have those breaks in the graph on f and have the derivative exist at those points. And the derivative clearly does exist at those points, right? You with me? Mm-hmm. Okay. What's this? Is this the next thing on your notes?
Yeah.
Okay, cool. Okay. If it's open, kind of free response-y work, then I expect good work. So let me communicate what I would like to see. I will cut you a little bit of slack here in that I'll let you do this kind of notation of the derivative. I'll come to that in a second. First and foremost, though, if it's continuous, then let's start with limits. The limit as x approaches 2 from the left. I'm not a big fan of using f of x there only. If I was taught that if you are given piecewise, you should identify what piece you're referring to during that part of the work. So on that part, I'm looking at 3x squared. And that needs to equal the limit as x goes to 2 from the right, which is x plus b. And that needs to be f at 2. In other words, f at 2 has to be defined when I say has to equal f of 2, that really is my mind saying, did they tell me what to do when x is 2? Did they define it at 2? Right? And they did. So what is the limit as x goes to 2 of the left-hand side? 12. What is the limit as x goes to 2 of the right-hand side? 2a plus b. And the f of 2 is not really an issue for me. It is defined, and it's the same as 12, so I'm just going to let that go. You with me? All right. Now then, if it's differentiable, then the derivative, remember the big idea here. This is so cool. You're talking about taking a parabola and a line and not only having them meet there, but also making the derivative smoothly transition from one into the other so there's no sharp turn, locally linear, all right? Now that would only happen if the slope, or A, is just perfectly chosen. Do you agree? Mm-hmm. Okay, that would be then to say that the slope, or the left-hand derivative, I'm going to do this in 2 steps, if you don't mind, just for clarity of notes, equals the right-hand derivative. What is the left-hand derivative? 6x. What is the right-hand derivative? A. That implies then that at 2, A needs to equal 12. All right, with that then, if A is 12, then in order for the curves to meet, B must be negative 12, right?
Yeah.
Okay. All right. Are you with me?
I don't do it.
Okay. Now, because it didn't say prove differentiability, it is okay in this case not to have to use the definition, not to use the definition of the derivative. Thank goodness, because that's... If it says prove, then doggone it, you're going to have to do that. Would you try that one on your own, just to make sure you are good at these more straightforward problems? Right, that makes sense. Did you get B as 1 and A as negative 1? All right. Now let's try. Is this what you have also? Okay. Let's talk about this. Does statement 1 hold true? F has a limit at x equal 2. Okay. When you talk limit, do you need to talk the left hand, right hand are the same and the point are the same, or just left hand, right hand? The limit is just about left hand, right hand. And are we probably good to go at the limit? Well, that's just about this, and at 2, the x minus 2 drops away, so the limit is 4. It feels like that is true. There is a limit, and it is 4. Do you agree? Is f continuous at x equal 2? No. Okay, so that's not true because the point doesn't fill the hole. This is a fill the hole kind of problem, so that's not good. And then what about 3? F is differentiable. Do I need to get into the derivatives? Why not? It's not continuous. It's not continuous. The differentiability is not even going to happen. It is only. All right, question? Okay. All right, proving not differentiable. We had one like this on the test, like I said, and didn't go great. So let's practice it, and then you'll practice it, and hopefully it'll be good. We know the derivative of the absolute value does not exist at 2 because there's a corner there. Prove why that's the case. Prove the derivative doesn't exist there using the definition of the derivative. So, let's go there. I am visual, so I'm going to draw myself a picture. All right. Now, the whole idea of the derivative is to take a point and a second point nearby, find the rate of change or the slope between those, and say what happens as the 2 points get closer and closer together. And that should be the same whether you take a point on the left of 2 or the right of 2. Will the slopes be the same? And you can see that they're not going to be, and that's what we're intending to prove. By the definition of the derivative, I strongly recommend you use the alternate definition. Generically speaking, what's the alternate definition of the derivative? The limit as x goes to a of f of x minus f of a over x minus a. All right. Now, in this case, then, that's the limit as x goes to 2 of f of x being the absolute value of x minus 2 minus f at a, which is 0 over x minus 2. Wait. All right. That's actually a limit we've done a lot of times here. What about as x goes to 2 from below? Like 1.9. If x is 1.9, what's 1.9 minus 2? Negative 0.1. Absolute value is 0.1. So 0.1 over negative 0.1 is negative 1. Now that'll be the case at all, and that's because you can see that slope is always negative 1. On the right-hand side, though, the limit as x goes to 1 from above, say 2.1. 2.1 minus 2 is 1.1 over 0.1, and that is positive 1 on the right-hand side. When you're above 2, the absolute value doesn't do anything. It's the same. And because those one-sided limits or the one-sided derivatives don't agree, the derivative at, let's just use the notation, f prime at 2 does not exist. Right? A limit can exist if the one-sided limits don't agree. The derivative is all about a limit, so that's one. Try it on your own. This one actually has a little more. You first show it's continuous, then show it's not differentiable. How we doing? Is that what you have? Okay. All right, that's as hard as you're gonna see on this topic, until you get to Calc 3, which is the derivatives of planar, so you're gonna love it. When you do three-dimensional, you don't approach from two sides, you approach from all sides, and then it's actually faces. It's so cool, you love it. Awesome. That's that. I did not give you this fun sheet yesterday. I guess I'll give you that Monday. So, I guess you just have questions on maybe two sets? Or not.
Yes.
Oops. Wait. I can. Alright, so let's go with set 80 first. Questions on set 80.
16 and 19.
Did you turn them in?
No, I turned.
Oh, I told you to turn them in?
Yeah.
I'm so mean, okay. 80 had a fundamental theorem of calculus part 2 problem I wanted to talk about, but I'll talk about that when I get it back. I'll see how you did first. So, 81 questions. 22? 22.
Wait, I have a question on this.
Yes, hit me.
Okay, so that part that says no, that's like uses the limit of the F on, right?
Yeah, that's correct.
So you're not, like, it's not valid, or you just want us to use the derivative?
Don't do this or I will throw up on your paper. Wow. Okay? No, it's not medical crap. You prove anything regarding the derivative, you're using the definition. That's the pro. When you're what? If it just says find the A, find the B, or total your choice, then do your crappy work. But if it's proved, it's fine. Okay? Yeah. So you did another good. Okay. So yeah, you had two 14s on last night home. You actually be surprised how much this happens. In such a case, that means 14 is important. I want you to do it twice. I'm kidding. You don't. You just scratch out the second. All right. Unless you're Carver, who would say, "I'll just find another one and do that." Where'd you? Carver. All right. And more. Okay, questions. I hear 22. And let's go with that. Okay.
We called it out. I said, you're up next. You're up next. Yeah, it's Michael. I'll drop one. I'll drop a thought.
We're still gonna figure it out.
No, I think it's
Hey. Did anybody get this one? This is a good question. You have to do a little bit of thinking. No? Possibly. Yeah, so you're on the right side. Were you looking at when I talked to this Jordan about that?
Yeah.
Okay, so you explain. Actually, let me catch up to you. I need the derivative first, so hang on just 1 minute. Y equals 4x squared plus 4kx plus 5 is the derivative. Do you agree?
Yeah.
And if it's going to be parallel to the x-axis, I want to find places where the derivative is 0. Now that's a quadratic. And so,
In the quadratic formula there, since in order to get real answers, the square root has to be greater than 0, so I set the number under the square root to 0.
okay. The only way, remember quadratic has three cases. It can have two real answers, one real answer, or two imaginary answers. If you want two real places, the derivative or this cube has horizontal tangents, then, like the man said, you need to set the, especially the quadratic part where the imaginaries come from, which is to say the root, b squared minus 4ac, that must come out positive in order for there to be two real solutions. And so if b is it 4 or k or 4k? 4k. So b squared then is 16k squared minus 4a is 4, c is 5. That radical, or the determinant, must be greater than 0. So 16k squared, what do you got there, minus 80?
It'll be equal to 0 as well.
Good question. If it's equal to 0, how many tangents will you have?
You'll just have one.
Yeah, there'll be two, but it'll be a double rooted, so it won't be unique. So yeah, it has to be strictly greater than. So k squared must be greater than 5. K must be, that's actually a disjunction. For squares to be greater than 5, k would either have to be
Greater than 5 or what?
greater than root 5 or
That's the negative root 5.
that's the root 5. We? That was a good question. Okay, other questions on 81? No? Okay. I'll walk around, let me know if you have questions.
So I started with this dAx plus b. So 1 equals 2a plus b, right? No, 2a. And so 5, so 2 minutes to 5 equals 2a. So I because I think you
Oh,
figured it out.
sorry.
Because that's because it wasn't that much. So 2 equals x squared plus b. Oh, because that's the other one. You don't plug that into the double. F prime. 5 equals 5 cubed 4 equals.
Hey, also I'll mention this,
Both of those
just
are
so you're
candidates,
aware.
not points.
Tomorrow you will be using one of my calculators, not your own. It's just a test security type deal. Yeah, basically, we had at least one student, and then every day I just handed my student my calculator with a kid in that class. Yeah, that is sad, isn't it? But at any rate, so you'll be using mine. How many 84s will I need? I know I have a couple. Right, so one, that's it. Okay, so I have a calculator for each of these kids. Understood? It is 12:39. You have 6 minutes, which you can get from.
That's efficient.
Oh yeah.
That's what he's like a 5 year, right?
I don't know. What is good with us? Just too much focus.
It's half the time that you give me. No, don't put it anywhere.
I don't know, that's the first time it's on. I just don't start giving the same initials. They're just don't have that culture.
I don't know if I'm ready. Yeah, honestly, if I'm on, I might just make very that makes sense considering it's literally what? What even, Michael? Are you trying to say?
What's that square root? Why don't any other teachers do that?
Why am I wrong, Michael?
Try to help.
Hold up, what if I try this? See that?
You're asking me.
Where am I wrong? Yeah, where am I wrong? What'd you get? Can I see it? Because I'm getting negative 0.417. Oh, that's what that is. But you shouldn't need that. You're taking assignment. Are you not? Are you? No, that's two. Well, A is a TA. TA is not the same